Móc đi. Quýt nhé. A Quang Hoàng xử lý nốt.
Yeah.
Cái đại tí nhé. Ừ. Ừ, dạ.
Cảm ơn anh Quang đã dậy sớm để giúp em móc nha.
Em Thịnh à là
Dạ em tên Thịnh.
hoặc Lâm đi chỗ khác rồi à? Ok ok. Bắt đầu nha. Okay. So hello Thịnh. Good morning. My name is Quang and today I will be your interviewer. So today I have one question for you. We are going to design Grab, yeah, because you are applying for Grab, so we are going to design Grab. Um, so to save our time, I will paste the requirement in the chat. Um, so I believe that you Grab before. I have a lot,
Ờ,
but we will focus on only three functional requirement. You see the requirement I put in the chat
oh, in chat. Okay.
in the
Let
Zoom.
me see. Where is it? Zoom sharing chat here, right? Okay. Um, all right, I see it. Rider put the start destination. Uh, wow. So you have customized the fare, right? Oh, not exactly, but we want the uh, predefine the price first, right? Then we can request, we can deny the trip. Okay. So let's say for this service, like, do we really want to like a rating? I said, do we want to have a rating rate after a ride success or what?
We do not care about it for now. Yeah.
Okay, so let's say if we want a matching booking service, let's say booking, we need like a matching mechanism.
Huh?
Okay,
Yeah, yeah, yeah.
then okay, so let's say the user, the driver. Um, so let me think if there is any other case that we could have in our system, like for the functional, for the non-functional part. Um, okay, so actually, I think these three and mine covers it like four non-functional requirement. So let's talk about the um, functional functional requirement. So,
Um,
yeah,
I
we
think you can.
want.
Sorry to interrupt. So maybe you can tie on the acrylic draw, so we can capture in the record.
Okay, okay,
Yeah.
okay. So say we have a functional requirements, um, and it is the common part. Yes.
Mm, perfect.
And for the functional requirements, let's say we want a location tracking. Um, we want a matching mechanism. So
Yeah.
let's say this is actually a functional requirement. And we might want to, let's say, probably logging the location for further investigation. Maybe we could perform the logging like that. And let's say we are using the applications from the user point of view, so we could get the current info of the trip book, okay? And well, we have the users, which is the rider, and we have the driver. Okay, so the affiliate. So we could there are two types of actors here. Let's say the user, the customer, and the driver. Both of them can get the current info of the trip. Let's say, what else do we need? In the real case scenario, when a driver accepted a trip, let's say the system held him from the other customers to book from his service. So let's say like a lock, let's say driver got a trip and he's being held by the system until trip finish.
Right. So
So
we have to make sure that it's one-on-one. So one driver cannot accept or have two trips.
one driver cannot have two trips on time in the meantime. And let's see, maybe we need
maybe one more point. That is like, so when driver got the notification, like you want to accept the trip or not, so he or she can only have like 10 seconds to accept or deny. So it's the time.
Okay, so it is already been listed in the non-functional. So what happened if a rider request and the driver could accept or deny, right? Let's say driver accept, then we to the matching phase, okay, and say returns the locations of the two actors, right? And driver reject so it's not the matching phase, just like go back to matching phase.
Yeah. So I think matching phase should be before, right? So after the rider request and
yes,
like say
okay, to the matching phase. This should be the matching phase. Okay, and after the matching phase, the two riders and drivers, they see each other. They could, after they pair up, okay, they go to the acceptance and reject phase. Okay, so that would make sense to you.
Let me see. I think that we only pair up like the one-on-one matching after the driver accept it, right?
Yeah, only one-on-one.
Yeah. So the pair up phase or step will be after the driver accept the trip, right? Because at that time we have a one-on-one, right?
Okay, so
when the driver requests, I think we only need to somehow send a notification to own the driver or something like that. Yeah.
Yeah, I got that. Accept. And notifications. I mean, send request to the server. Okay. And the drivers would say driver pull, let's say pull the request pull. Okay, pull for the request pull for the matching, for the matches, the possibly match rider. So is this is this make sense to you? Right, this one.
Yeah, go ahead. Yeah.
Okay. So let's assume we have let's say a daily active user of 100 million. So because I think like say Grab is kind of a big systems. We deal with a lot of users, let's say. Okay, maybe we could give it 110, let's say, for 100 million customers and 10 millions of drivers, let's say, just assuming that. And I'm gonna assume like one customer gonna make one request, maybe one request per day. And so we have like daily payload is around 100 million requests a day. So let's say we know that for a day we have this amount of seconds. So the what? So the request per second. So the request per second, I call this VPS. Query per second is around. Maybe I'm not good at math, so I will use this one. So 10 to the power 8 divided by. Okay, so around 1,200.
Yeah.
Say 1,200. Say we have to save the say let's talk about the right structures of the request, right? Structures. What would be the structures of it? So model structures of it is say
I think you can start by listing out all the entity or the table name you have. No need to go into the column.
Okay.
Can
say we have a user. A user would have the ID, which is the UUID. Okay, just start with it first. Then we have the driver, and let's say we could have a say a trip, right? Inside a trip, we have a driver and we have a user, right?
Okay.
So we could have some things like locations. Locations. So we have something like a trip location. We have user ID, we have driver ID, we have the location. I call this just a location object for simplicity. And we also have a, let's say, trip ID. So does this make sense to you?
Why do you have a location, trip location table? Like, what is it for?
I think to track the current state of the trip, or yeah, track the current state, or can we separate it into a separate entity?
No. So I think the trip will have two location, right? The location of the user and
Yes.
driver.
Oh
So
yeah, yeah. So okay. So I think if we say so, then it's just simply a location.
yeah, we only need to track
Yes.
the location of the user, I guess.
Okay, of the user. Because let's say after it pair up, it match. Let's say both the user and the drivers are on a single point on the map, right? The location only, we take into account the user only. And let's say,
Okay.
I really want to go into the estimation of the let's say the data storage.
Okay, let's I think we can skip that part.
What? Sorry.
And I think we can skip that.
Okay, we yeah. So you assume that I could go into the high level design right now?
Oh
Or
yeah, you can
yeah,
go,
yeah.
yeah, API design first, I think.
Oh yeah. So let's say we have a service. Just draw the actors. Okay, I'm gonna draw the actors. So this would be the driver, and we have the user, customer, and driver. So we could have an entity that is called the to retrieve the info or to make a request to the systems. We could have, like, say, two services for drivers and the customers. I want to separate them, so we could have, say, here. I call this the user service. Okay, should be customer. And another service is the driver service. Okay, so I think on the first hand, let's say if a user want to get the info from the trip, or just call to these two service, I'm gonna assume it at first, right? So interact with this.
Yeah.
And based on what we say the writer, let's say they want to make a request, let's say here, add a request. Let's write. Okay, just call it to the customer service. And we could have, let's say, a black box here. Just call it a black box. Then I'm gonna make everything clear after.
Yeah.
Black box. Then they do something to the black box, and then the drivers are going to interact with this. Okay, so let's say trip added. Okay. Then the driver is going to interact with the trips. Then it returns to the customer and returns the info back to the user. Let's say if a trip is matched, right? And matching system driver can accept. Okay, so I am going to resolve this black box here. Okay, let's say the first thing we want is a matching mechanism. Let's say I will create a matching service. Okay, matching service. So this black box, the first component should be matching service here. Going to the matching service. And then the matching service will like do something with the location service, because we want to update the locations of the customers and the drivers before the trip and after the trip, right? Location service like okay, after the match finished, then it will fire something to the location service to, like, say, store the current locations of the two users and the driver. So to say the phase is before the customer get into the car of the driver. Right. So here the driver could get info from the location service after the trip. Okay, let me read the requirements again, then get the estimation fee. So I think the heavy workload would be stayed on the matching service, because it handles like the price of a trip, like this, like matching service handle price filtering. Okay, filtering here. Then okay, then it will handle the location. You get the location and pair up with the customer and drivers. Say we want a shortest driver to match. I mean nearest. Yeah. Then we have the request. Then the driver could accept or could deny, right? Let's say if the driver is here, let's say if he accept, then it will fire back the request to the user. Yeah, and if he reject, then it will also respond to the user.
Okay.
Okay. Then let's say after a trip is matched, then it's going to log the state of the driver. Just say log. Okay. Log the state. So, I mean, okay, so here on this driver part, I could have, let's say, have the status of the user, of the driver, sorry. Status would be available or not available. And to trip in the meantime, current info. And so as far as I dive in, for the request and the request from the rider, the deny and accept from the driver. So do you have any feedback on this? Because
So how do you, okay. So how do you update the location of the driver?
okay, update the location on the driver, right? So here, the drivers is connect directly to the location service. So his location would be real time, would update it, let's say for 5 seconds, I think. So maybe like 5 seconds interval, updating the location. So that makes sense because we want the locations to update for both the user and customer, but heavily the location should be update on the driver. So there would be a connection directly from the driver service to the location service.
Mm. And okay, so how do you make sure that the driver can have only a limited time to accept or deny a match?
Oh, so we consider about the interval of the request, the times, the max limit times for a request. So okay, I think so. That would be the responsibilities of the matching service. Let's say if if he wait for the trip, let's say if he wait for the trip too long, then it will cancel the state of the trip and then respond back to the users and respond to the driver saying that the trip was canceled due to time limit. So um, okay, let me go to the document again. Say rider send. So probably let's say I want another component. Let's say I call it the notification service.
Okay.
Yeah. So like we know that in the real system, when the drivers is getting close to the bookers, the customer, it fire a notification saying that your driver is coming. So I think we could have a connected between the location service, I mean, just the matching service and the notification service. So the notification service will asynchronously send back the info to directly to the user and send it to the driver for the real-time updating I mean, not real time, but let's say we have a small delay of the location update. So, yeah. Let's go to the part where both of the, yeah.
Okay. So I think the important part of this system is the matching service and the location service, right?
Yes.
Because when you do matching, you have a location of the customer and you will need to look for nearby driver, right?
Yes, yes.
You deep dive a little bit about that part. Like how do you find the nearest driver given that the customer location?
Okay, so I would talk about, let's say, go from bottom up. I want to talk about, let's say, the database first. We know that some database support the location filterings. Let's say we have, as far as I know, Redis is a database that support the geo algorithm. I'm not remember exactly what it's called, geo hash or what? Redis? Geo hash, right?
Yeah.
Okay, so this partitions the data into chunks, and it would help us a little bit in the matching system. Let's say in the real world scenarios, we have many grid in the map. And if we use Redis this way, we could filter the location first. Let's say we have a grid that look like this, a grid. Then user making a request on this grid, and we have multiple drivers. Let's say the green is the driver. Okay, we have here, we have here, here. So at first, let's say we could cover up all the adjacent grid to find the possible driver. Let's say we're covering the nine cells here. So we found, let's say, 3 drivers. We found 3 drivers, and then we will perform, and after that, we will perform the some kind of algorithm, like find the shortest path, maybe the shortest path based on the price. If we pay higher price, it could match the driver faster, like using a premium service. Suppose maybe if we look at the map, we saw that, okay, this should be the closest driver, right? But actually in real life, there could be a traffic jams here. So this would not be the fastest driver to come. And then somehow we find out this is the closest driver. So how do you think about this?
I think it should work, but I have one question. So are you suggesting that we store the location in Redis
Yes.
or in the
So
data?
okay, so the use case here is that we want to query the location real fast.
Yes.
So it is best to store it in memory, and Redis is good for this. But in the long terms, let's say we want to track the locations of the driver, and maybe the driver could drive a very long. He could stay in the north of Vietnam, probably in the south. But we want to use that for analytic purpose. Let's say we in the long terms for logging. Let's say we could use like non-SQL for logging the location.
Okay.
Oh yeah. So for non-SQL, let's say we have 2 examples. We could use MongoDB or we could use Cassandra. Based on my experience, if we want a really high consistencies and queries using index, it is at best to use MongoDB. However, let's say if we just want to store the locations and we want to run a linear process to digest that information, we know that location is updated on real times, right? If the location, say we have locality, if users is on the Ho Chi Minh City, we know that he cannot jump immediately to Da Nang, let's say. So it is predictable. So when the data is linear and predictable, we could use Cassandra, Cassandra as non-SQL for the logging. So you think it's okay, right?
Yeah, I think so. So that means you need to have something
trade-off
done from Redis to non-SQL database, like asynchronously, right? Like
yeah. So for this, let's say we could have things like the message queue. Let's say we pipe everything into a queue. I mean, how should I draw a queue here? Say if I have a queue, right, I could partition it. So sorry, my drawing is not that good.
I see. Yeah.
Yeah. Then after the locations, let's say if you got update driver or user location, then it's gonna write to the queue. Okay, right.
Okay.
Right to the queue. I push to the queue, I'm sorry. And then this locking mechanism, then it just get the message from the queue and just do its own thing, right? For this part, Redis and hash, let's say the location service will update the let's say, okay. Yep, so get the location from the Redis, so to perform a fast lookup. Yeah, so in real world, let's say we have a user that, I mean, the drivers that he drive from these, he drive to here, then he drive to this point, then this point. I mean, let's say if we scan the map, right? If we scan the map, we want to look up the location real fast, and this is where Redis show its power. We don't have to dive into a logging database or a SQL database. We just get it immediately. But yeah, so
I think that makes sense. Another question is follow up a bit. So as you know, on a really busy day, for example, like GN or like holiday, you will have a lot of requests from user, right? To request.
yes.
So I think the customer service and even the matching service, it will be really busy, maybe get overloaded. So how do you prevent that?
Okay, so during busy day, let's say this service could die, right? This could die, leading to our whole system crash. So in this case, we know that the drivers is usually less than the rider. Say the riders always higher. Let's say we specified it here, okay? Which means it is becoming pretty read heavy, I think, a little bit read heavy. So in that case, I might want to put the put the service, let's say, put it behind the load balancers. And so if the reason I want to put it behind a load balancer is that we could scale the customer service easily, because we loosely, not loosely, okay, call it here. So okay. Put everything to the right a little bit. This one. And put behind a load balancers. I put it here. Load balancers. In terms of load balancers, we have two kinds of load balancers. We have layer 4 load balancers and layer 7 load balancers. In this case, we cannot use the layer 4 load balancers because we need to read the metadata of the request. Let's say we have API version 1 customer, then so it will need to read the metadata of the request or read the part of it. So we cannot use layer 4. Okay, I was assuming that we are using a layer 7.
Okay. Okay, so every request will go to the load balancer first.
Yes.
It will forward to customer service.
Okay, so I mean, load balancers here is probably, let's say, if it is an API gateway. From my perspective, API gateway and load balancers could be a single entity that doing like two things at once. Let's say, for example, like Nginx, it can also be a gateway and a load balancer in a single instance. Yep. So it will forward here to the request to many customer service, because I could remove the single points of failure. Okay, make the component. Yeah.
Okay, how about the matching service?
Okay, so
We have
matching service.
a lot of traffic from customer service, but the matching service, I think it will need to do a lot of things, right? Because it
Yes.
call the notification, it call the location service, and estimate the fare and do the matching. So the rate that matching service can handle is, I think it is less than the customer service, right? Just like
Yeah,
you,
for sure.
how do we handle that?
Okay, so there are two things that comes to my mind. So the first thing is that we are doing exactly the same as we are doing for the customer service. Let's say, however, when we scale it up, let's say we have to make sure that the matching service respond correctly, right? So one service is, let's say, we have to make sure the transaction is consistent, because otherwise the location might update and get the wrong, because two matching service could, let's say, serve, let's say we have two customer service, and it's like, say, it somehow get the system wrong. So I don't think like scaling the matching service would be the solution here. Because it is a core service, right?
Yeah.
So we don't want to directly connect the customer service to the matching service like this. So if we want to decoupling the component, it is at best to use the queue, as far as I know, right? Yeah, the customer service will fire the request to the queue, and then same for this, and same for the customer service here. And the matching service will pull the request to it, like this one. So we successfully decoupling the component matching service and the customer service. So in case we want to scale the matching service, this one, we want to scale it, it is much easier if we use the queue. Okay, so we have many matching service and it will, yeah, just get the message from the queue. So what do you think?
I get your point. Yeah, I think it makes sense to do that, like because we have a mid class in the UPS here. So a buffer like a queue can handle that well. Okay, I think I have another question. So let's say after the matching service, uh, so in my understanding, in your system, the matching service will given the requested customer, it will file a list of that nearby driver, right? And then it will send a notification to the driver, right?
Um,
Is that correct?
after it make the request, right? It match the service. It talks to the locations. Then it respond to the driver, so the driver knows. Okay, I have a match from the rider who. Okay, I mean,
Okay.
yeah, it's the notification service that will. If we do it like that way, like we want to ask ourselves, how would the customer know that a driver our uh, match the drive, right? The ride. So the notification service will fire a notification to the users, and then after the user know, okay, so the driver accept my request, then I'm gonna call to the customer service to get the info of uh, the trip.
Okay.
Okay, I just write here. So like,
So yeah. So I think in real world, uh, the driver he or she will get one notification about your ride because we will not send a lot of notification to driver, right? Because it will like bombard him with a lot of notification about the ride request. I think in the phone he or she only see one request, right? But in this case, let's say you have two customer or 10 customer, and for example, the matching service somehow find that the same driver satisfy the requirement. So it will send 10 notification to the driver. Is it not good, I think? So how do you prevent that? Like how do we make sure that the matching service only send one notification to driver?
okay. So what you're talking is like we're dealing with a terms that call idempotency. Idempotency is that let's say one request, it has to be unique. So when we send a request, let's say we put something to our headers. Let's say we have, let's say, idempotency, idempotency token. Say that. So file request here. So this, I think, will be stored as a state in our system, sent to a notification service, and after the notification service that it, let's say, a matching service that know that what, I mean, so it makes a request unique, right? So probably in the state you are concerning, with idempotency managed, it will fire the notifications one. So I mean, fire to the customer, right?
Yeah. For the driver, I think one way you could do is like because you in your table, in the driver table database,
Yeah.
you have a status, right?
Oh yeah,
So if
status.
yeah, so
Okay, let me think
I
on
think you
this.
can use that. For example, if we already send the notification to the driver, we change the status to request sent, right?
Okay, so we have a intermediate state. This available. So it's act like a lock, right? A
Mm.
locking, yeah. So
So if we already
it,
send and we do not send again until
yes,
driver change the status like accept or reject. At that time we can send again, right?
yeah. So we have an intermediate state. So it means we have to deal with um, a revert logic. Let's say if the drivers reject the booking, reject the trip, then it will have to jump back to the available state.
Right.
We have to make sure that because we have more state. Um, so
But I think we need to handle an SK here. Let's say we send a notification and the driver never get back. He turn off the phone or
okay.
does not respond. So that means the status will stuck forever, right?
Oh, okay. Can I have a full flow? Let's say we we are the customer file a request.
Mm.
The driver accept it, right? And somehow the user doesn't get update from the notification service.
No, what I mean is like, so the customers request a ride, the matching service send out the notification to the driver. Let's say like accept a request, right? And then at that time, we already changed the status of the driver to request sent, right?
Yes, request sent.
But then the driver never respond to that. Like he turn off the phone or he just ignore the notification. So that mean the status in the driver table, it will be always request sent. That means we
Okay.
will stuck with that status forever, right? How do we?
Yes. So work around with this lock state. I think we could like the naive solution is that we use a cron checker. Let's say we have to say just a naive solution, not the best solution, I think. Like we have a status cleanup, status cleanup, and this will let's say it act as a asynchronous service, just get the info from the driver, and if it saw that it is request send um, for a long time, then it will toggle the available back, toggle the status to the available. Let's say we could have if we could have like last status update, it is a timestamp. Okay, so it will toggle it back, but I don't think it is the best solution here. Um, let me think on this. Okay, so a driver send.
Yeah, I think we need some mechanism to automatically turn that to automation after a timeout, like time to leave, something like that.
Time to leave. A trigger like, or we could do it. Let's say manually. Let's say if the drivers he doesn't respond, that means he is offline. And when he get back online, he could, let's say, switch the state to the available by himself, right? Yeah. In that case, we let the drivers actively switching his state. We don't have to deal with automation's cron job here. So, do you have any feedback on this? And
let's see. Vacation service. Yeah, I think it's look reasonable for me. I think.
Well, do you want me to jump into any upgrade for the futures? Like there might be global scaling or dealing with any upgrade?
Yeah, we have a few minutes left. I think we can talk a bit about the scalability. Let's say you want to support like multiple regions, for example, in Vietnam and in Singapore and other city. How do you handle that?
Okay. So first thing first, I want to talk is what for the customer service part, we know that for different regions, we have different rules to retrieve and storing data for the citizens, right? Like for example, on the Europe, yeah. So since we have these multiple service, we have multiple regions based on the map. We could deploy a cluster of services to multiple regions because we already split the service into, let's say, small component. It's easy to deploy. And
Can we do the same for the location service?
I
I think
think,
I don't need to
yeah,
one.
yeah, it's easy. We know that the for the specific sales, we know that there would be no sales we use if it is in the ocean. I mean, why would we care about the part that is in the ocean, right? We only care about the sales that involve land, right? So I think, yeah. And
So I guess you for each city or each region, we have a separate Redis real hash for it. Is that correct?
yeah, for different regions, I mean the big regions, like say the north, the north, the North America or the Europe regions, we have different geohash and different location service. And as far as as I talked about the Cassandra is super strong. It is really strong in scaling globally because its approach is like say eventual consistencies. So we can scale this Cassandra cluster easily, okay, without struggling. And I mean, for better performance, like for the connections between the services, we could use gRPC instead of using the HTTP, because we know that for this part, it should be HTTP from the client to the gateway. And then we can cancel the SSL or SSL terminate to make our component, let's say it can contact each other faster. Okay, we can upgrade using gRPC. And so, okay, so if you want to scale globally, deploying multiple regions, let's say our database should include sharding. Let's say if the data is growing too big, right? And we have to shard. Let's say we want to deploy globally. It is at best to shard with the location. But in the case, some regions have more users than the others. I think it is at best to group this location and or split it into smaller chunks. Like in the US, we sort based on the state. For example, in the Europe, we sort based on the country, like that, and we involve many components into the sorting key so that we can split the shards equally sized. So the cluster could perform at best performance, I think.
Okay. Instead of sharding, because you have a customer table and a driver table, so do you think it is, so we have two options, shard by user ID or shard by location, as you say. Yeah, what do you think? What do you think? Like, which way is better? Like,
Obviously, we are dealing with a close proximity service. We base a lot on the location, so I think it's best to short base on the location. Let's say the user on the Europe regions, they rarely move on to another regions, like move to Southeast Asia, like Vietnam. So if we short the data based on the location, we put that data, we we stored it on the Europe region so that the user could get the data faster. Yeah, so this cache could get the data. I mean, it's closer, so it's faster, right?
understand. All right. Running out of time. I think I will send the written feedback later on the chat. Can you share this to me? I share this.
I'll share this one. Wow, where is it? This. You saw it?
Yes, I got it. I got it. Ok. Để tí nữa anh viết feedback lên Facebook nhé.
Yeah, cảm ơn anh. Rung quá anh ơi. Em học ở trên cái khóa anh có vẽ cái kia nhưng mà em thấy nó không có familiar với em lắm cho nên em mới kiểu
Anh nghĩ
vẽ
là
một cái yeah.
nào phỏng vấn thật thì chắc là dùng Draw.io đi cho nó vẽ cho nó đẹp.
Dạ, Royal. Tại em
Có
không có biết dùng Royal anh.
nhiều cái nhiều cái icon đấy. Em đỡ phải vẽ người vẽ Q kiểu ấy, drop vào thôi.
Dạ,
Hoặc là hình như cái thằng Eclipse này nó cũng có mấy cái library em click, em bấm vào cái nút library.
dạ, để em tìm hiểu.
Yeah. Thì nó có mấy cái hình vẽ sẵn đấy.
Dạ,
Và có em đã học bài này chứ hay là em đã học cái khóa đấy chứ?
em chưa có học anh ơi. Em chưa học nhưng mà em trả tiền trước xong rồi em lấy cái slide em đọc, em mới đọc một tuần nay à. Tuần nay em đọc hết hai cái đống mấy chục cái slide của cái System Design 1 với 2 luôn á.
Trả tiền rồi thì xin Lâm cái gì ta, record mà đọc mà xem.
Dạ.
Nhiều Grab thì anh nghĩ là nó hỏi quanh quẩn mấy cái liên quan đến Grab thôi.
Dạ, nhưng mà em sợ anh, tại vì trước đây á, cái team của em á, là làm về observability, cái người phỏng vấn em là làm infra, mà trước đây có một ông á, là đã bị hỏi cái câu là hỏi design rate limiter á,
Ừ.
design con rate limiter á, nên em cũng có coi cái rate limiter đó, mà mỗi người lại trên YouTube thì mỗi người họ lại nói mỗi kiểu anh, có người thì focus cái này, người khác thì focus cái khác á, nên em cũng bị hoang mang.
Cái đấy thì em phải tức là có một vài cái mình bắt buộc phải nói, còn có những cái khác ấy, thì mình phải đoán được ý của thằng interviewer ấy.
Dạ.